Good morning, everybody. Doopy-doopy-doo. Welcome to my couch. Class, sorry. All right. So we left off with monohybrid cross. Are you going to photobomb my whiteboard again, dog? Ah, she's gone the other way. It's a tough life being a dog. Sorry, obligatory dog shot. There is she. There's one. And there's the other one. Doing their doggy thing of just lying there, I guess. Yeah, she's wearing a shirt because she had an operation on Friday to stick her skin back to where it should be on her chest. So when she was, before we started fostering her, she had a massive abscess on her chest, which basically blew off a large chunk of her skin. And she had just kind of bare muscle for a while. And it grew back, sort of, but it didn't grow back in quite the right way. So they just basically unstuck it all and then stuck it back together again. So that's why she has a shirt on, so that she doesn't bite her bandages and stuff. She's very cute though. Yeah, you are. Okay, go back that way. That's it. Good dog. Yeah, she is a survivor. She's used up about 4 of her 9 lives already. If you know, dogs are the same as cats. That's for sure. All right, so yeah, she is. She is indeed. All right, this is where we ended up on Friday. And what I want to do is quickly go through just kind of the principles of this. Well, not really the principles, practice. There you go, that's a better word. This is going to annoy my dog a little bit. So, let's get, yeah, it's all right, dog. I'm not going to harm you. Super jumpy dog. All right, so let's get this. Here's my computer. There we go. And let's quit the share. Oh. All right, so that should be a bit bigger. Bring that a little closer. There we go. It's always a little bit of a struggle figuring out the best position. All right, so hopefully that should be relatively clear. Let's get my pens. All right, hopefully a little bit. It's not going to get all feisty and chew on them. There's one that she did chew on, for example. Find her a toy to chew on instead of my pens. Okay, so monohybrid cross. It's all right. And the reason I'm doing this is because I want you to really get what's going on. Because when we start on the dihybrid cross today, it's going to be much more complicated, right? So I really want you to understand the practice, right? Good habits, essentially. So we always start off with our P1 generation. What are the genotypes of the P1 generation people? This is a question to the class, just in case. All right, homozygous dominant, thank you, Isaiah. I'm going to use, actually, yeah, let's use H's. They're a good letter to use. All right, what's the other parent? One is homozygous dominant, the other one must be, no, Fernando? Good guess though. No, it's still P1, Isaiah. Oh, I see what you're doing. Parent 2, right. Right. And the reason, Fernanda, is that the parental generation are always homozygous. Right, so you're either homozygous dominant or homozygous recessive. Doesn't really matter which way around it is. Cool. Okay, so one thing that's not in that diagram is that these will produce only one type of allele each. Gamete, sorry, there. That's not a good start for Monday morning. Right, and gametes are what we care about because gametes are what combine to create the next generation, right? The individuals of the next generation. Okay, so, and also it makes our life easier because all you have to do then is kind of put those two together, and now you get the heterozygous F1 generation. Actually, I'm just going to scooch this up a little bit to give myself some more space. So this was what you were probably thinking of, Fernanda, earlier. Actually. Okay, that makes sense so far? Actually, I do like the other way of doing it. Sorry, been a little bit changeable today. Right, and this will be our F1 generation. Right, relatively simple so far. We apply the same principle. What gametes can this individual produce? Questions to the class. What gametes are we going to get for this one? Yeah, that was quick, Stephanie. Exactly. We're going to get a dominant allele. We're going to get a recessive allele. Okay, so law of segregation. What ratio are we going to get these two in? What's the ratio of the dominant allele or gametes containing the dominant allele to that? Ah, see, I'm always glad I asked this question. What, how can I put it? Is the process of separating alleles into gametes random or not? It's random. So if it's random and you have two different options, exactly, it's going to be a 1-to-1 ratio, right? That's the law of segregation. Which allele you get in any gamete is totally random if you have two different alleles, right? So this is going to be a 1-to-1 ratio. Okay, so now what we do is we take two lots of these, right? We're going to take two individuals, one over here and then one over here. And we'll get to where the 3-to-1 ratio comes in a little bit. Okay, so now we have two individuals. We have one F1 here and we have one F1 here. They're going to produce their gametes. And the same applies for this individual, 1-to-1 ratio, right? So you have equal probability of getting a dominant versus a recessive allele. And then you do the same as up here. It's a little more complicated, but it's still the same principle. You just stick the alleles together, following what you've written up here. And technically, this is little h, big H, if I'm being pedantic, but it doesn't actually matter. And then those H's look a little weird. Never mind. So this is what we get in terms of genotypes. right? We have, I'm going to run out of colors here. One of these. Yeah, where can I put that? Two of these to one of these. Right, so we go 1 to 2 to 1 genotype ratio, but we're not actually super interested in the genotype ratio. What we care about is the phenotype ratio. Right, so the phenotype ratio instead and there's supposed to be an E at the end of phenotype, just ran out of space. Instead, we go, essentially, do we have a dominant allele? If we have a dominant allele, we have the dominant phenotype. So we have dominant, 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 right? Even though these have a recessive allele, it doesn't matter. That recessive allele is masked by the dominant allele. So all we see is this dominant allele and this dominant allele. We never see the recessive allele in these individuals, in heterozygotes. And so now instead, we have a 3 to, oh, where's my purple? To 1 ratio. And that is what we care about, because that's what we can see as well. Okay. Questions? Does that make sense? Awesome. Good. And I've gone through in a very deliberate way because I want particularly the alleles, like the gametes, the alleles in the gametes there. I want that to get across because when we go into the dihybrid cross, we have a lot more, we have twice as many different gametes. All right, take a picture of that. Take a picture of the pup. Yes, you're very pretty too. Well, the pup's like, wait, why are you taking a picture of me? Okay, let's get rid of this. Okay, just turn you around. The moving things around. Okay, so that's relatively straightforward. And one thing as well, I can't remember if I mentioned this last class, but I'll mention it again anyway, is it shouldn't matter which way round you do this. Oh, I did mention how you can tell which of the parents is dominant. Did I do that? I have to check because I did for the other one. I'm not sure whether I did with this section. All right, well, it doesn't hurt to reiterate anyway. Even if you don't have the genotype of these parents, you can figure out which one is homozygous dominant simply by looking at the F1 generation. Because the F1 generation will always express the dominant phenotype because it's heterozygous. And so if it's round seeds here, then you know that round seeds is the dominant phenotype, and these are homozygous dominant. So that's a kind of a little trick, essentially, that you can use. So another thing that's really important to get across for autosomal genes, actually, this is worth bringing up. Autosomal genes are genes, as you guess, on autosomes. And basically that means they're not on sex chromosomes. Right, and then you have, you know, sex-linked genes. So if these genes that we're looking at are on autosomes, they're autosomal genes, it doesn't matter which way around you do the cross. It doesn't matter whether the male is the one given flower, or I don't know much about flowers, to be honest. I wish I paid more attention in botany. Doesn't matter whether the dominant parent is male or female and the recessive parent is male or female. You should get exactly the same outcome. Now, that's not necessarily the case in sex-linked genes, which is a non-Mendelian process. Okay, so law of segregation, we've already covered that. That's pretty straightforward. Okay, not going to do this. Now we go into the test cross. Okay, so the dominant phenotype, as you can tell from up here, could be either heterozygous or it could be homozygous dominant, because you only need one dominant allele to express the dominant phenotype. So if you have an individual expressing the dominant phenotype, let's say you have a dog, you know, that you buy and you want to breed it, and you're told it's a true breed, right? Since, you know, King George II, direct lineage, yada, 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 whatever they do, and they sell dogs. And you're like, well, not too sure about that. And before you get on with the business of making lots of, you know, puppies to sell or whatever dog breeders do, you want to test. How do we test whether this dog is true breeding or not? Essentially, if it's homozygous or not. And so the way that you do that is with a test cross, right? So I'm going to just go back to the board. It's all laid out quite nicely here, but it's done in a lot of words and stuff. So I think it's a lot easier to do it on the board instead. So let's just rotate back again. And down. There you go. Modern technology is a wonder. How about that for efficiency? Saved all that time and ran out the cross. All right, so essentially we could have either, let's do this in color actually, make it pop out a little bit. We could have either homozygous dominant, or we could have heterozygous. So that's our question mark. Which of these do we have? So what individual would you have to cross? What genotype of an individual would you have to cross these into to be able to figure out whether or not they have a recessive allele present? Yeah, excellent, Stephanie. You'd need a homozygous recessive, because if you have a dominant allele, that will potentially mask, again, like in this heterozygous, the presence of this recessive allele. Right? And good job too, Caitlin, as well. So these are our question marks. And this will be our tester. I think that's a word. Looks good to me. Right. And it only really works if that individual is homozygous recessive, right? And that's actually a pretty easy genotype to figure out, because if it's homozygous recessive, it'll display the recessive phenotype, right? So you're guaranteed what the genotype of this individual is. 100%, you know, without a shadow of a doubt, because this is expressing the recessive phenotype. Okay, so this is going to produce only, pardon me, recessive alleles, what gametes we're going to get from our, if this individual is homozygous dominant, what gamete we're going to get from this individual? Right, it's going to be the dominant allele. And so when you put those together, you'll get a heterozygous, actually let's be fancy, a heterozygous individual, right? And this will display, well, essentially, you'll have 100% dominant phenotype. So if you do your cross and you get only, I don't know, whatever the dominant phenotype would be, like super fluffy ears or something, then that tells you that your parent up here is homozygous dominant. Okay, now let's do the same for this individual. What gametes we're going to get, and I bang away at this because it's important. What gametes we're going to get for this individual, this heterozygote. We're going to get two different ones. That's correct, Isaiah. What are they going to be? What gametes are you going to get? Almost. Yes, Stephanie and Isaiah, 100% correct. Caitlin, you're jumping ahead. You are correct in terms of the offspring. We're talking about the gametes, though. No worries, that's cool. But so that's good because you're getting the idea. But one thing I want to stress is that until you're like really good at this, you may be already, but until you are for sure, if you write out all the steps, you can't get it wrong, right? I'm a big fan of like the whole tortoise versus the hare deal. You know, it's always better just to kind of be methodical, just write stuff out, and then you're never going to get it wrong. Most times, if you really understand it, you can kind of skip all that. But even so, it's kind of worth just going slow first, just in case. And so now you're going to get this individual and, oh, excuse me, this individual. Right, so Kayleen, you were right. And Fernando as well. These are the individuals that you're going to get. Now, what's the proportion of gametes for this individual in terms of dominant versus recessive? It's 1-to-1. So what's going to be the ratio of offspring dominant to recessive in this generation? The only thing that's different between them is the gametes that they get from there. Yeah, exactly. Just type out the same thing again. So you're going to get a 1-to-1 ratio of dominant to recessive. And if you get that or something close to it, that tells you that the parent up here was heterozygous. That is a test cross. Okay, questions? And this is something that guarantee you will be on the exam. Almost certainly I'll do something like, what would I write as a question? I don't know, I say a farmer has a prize cow that he mates with a, his neighbor's scraggly looking cow. And he gets I don't know, 3 beautiful cows and 3 scraggly cows. What's the genotype of the his prize cow, for example? That would be one question, right? And as soon as you see that kind of deal, particularly 50-50, right, which you do not get from a monohybrid cross, that's a 3-to-1. If you see 50-50 and he's like, oh, okay, we're crossing, hang on, we're crossing something with a homozygous, what sounds like a homozygous recessive individual, that's a test cross. And if it's a test cross, you only have 2 potential outcomes: dominant or 1-to-1 dominant to recessive. So you will get questions on that, probably a couple of them in exam 1 at least a couple. Anybody got any questions? If so, speak up. This way tends to make sense for many students, but not all students. So if it doesn't make sense to you, we'll work through it in a different way. So the tester is always homozygous recessive. Stephanie, what we're interested in is what's the genotype of our unknown. It could be either, if it's dominant, hang on a sec, Alex Ray, I'll get to your question in a moment. If it's a dominant phenotype, it could be either heterozygous or homozygous dominant. The only way to, yes, that's correct, Stephanie. The unknown in that scenario was the prize cow. I'm sorry, should have mentioned that. So this is what we're trying to figure out. What's the genotype of this individual? It could be this one, or it could be this one. The only way to know is to look at the offspring when you cross it to a homozygous recessive. And Alex Ray, that is, you put an exclamation mark, exactly correct. Monohybrid cross, the ratio will always be 3-to-1. Yeah, so that's definitely, that was not what I would call my most finely crafted exam question. Yes, I will be clear as to which, actually it doesn't really matter thinking about it. So yes, the assumption is that the scraggly cow is recessive, but it doesn't matter because all you care about is the ratio coming out of that cross. So if you could even have prize cow and a, well, if it was prize cow and a scraggly cow and all of the offspring were prize cows, then you'd know that the prize cow is dominant and, or prize phenotype, I guess, and that the prize cow is homozygous dominant. If you get a 1-to-1 ratio, you don't actually necessarily know which of these, if you're not told, which of these is is homozygous recessive and which is heterozygous, which is dominant, which is recessive. But it doesn't actually matter because all you care about is, do I have a 1-to-1 ratio or do I have a 100% dominant outcome? I just noticed. Distracting pause in the background. And also another thing to be super clear on too is this is nothing like a monohybrid cross, because in a monohybrid cross, you're crossing 2 of these two together to get the 3-to-1 ratio. Right, so this looks nothing like a monohybrid cross. A monohybrid cross is always 2 true breeding parents, heterozygous F1, 3-to-1 ratio of dominant to recessive in the F2 generation. So even if you just see a 1-to-1 ratio, automatically it's not a monohybrid cross. It has to be something else. So those are essentially kind of shortcuts. You can work through them completely, or you can just look at it and go, ooh, 1-to-1 ratio, more or less. Maybe it's going to be, you know, like 10-9 or, you know, 20-22. Close enough to 1-to-1 ratio. If it's a 1-to-1 ratio, then it's got to be a test cross. If it's a 3-to-1 ratio, got to be monohybrid. If it's a 9-to-3 to 3-to-1 ratio, it's got to be a dihybrid. Speaking of which, we got to get cracking on that. Any more questions? Okay, cool. This is where I really wish I had a bigger one of these. Monohybrid crosses are never 1-to-1 ratios. Never, absolutely ever. Never, never, never. So if you see a 1-to-1 ratio in the progeny of a cross, it's a test cross. Also, you'll have a dominant individual crossed with a recessive. My dog's snoring, isn't that crazy? Right, so all right, back in business. Not sure what happened there. I think I temporarily lost the internet. All right, back again. And if you see a 3-to-1 ratio in the progeny, oops, that's a monohybrid cross. So you'll be you'll have 2 heterozygotes. There you go. So both the outcome in terms of what you get in the progeny, and I just noticed there's a smiley face floating around behind me, and also the parents that contribute, that make those progeny, will be different. So testing, like looking at either of those should be flags to tell you this is what I'm working with. Okay, does that help? Cool. All right, there we are. Back again. Cool, I'm glad. Good question though. As I say, it's often like this will make sense to me, right? But it doesn't necessarily, because I've done it so many times, but it's not necessarily going to make sense to you first time. So these questions are really, really useful. Okay, dihybrid crosses. Now, the principles are exactly the same as for a monohybrid cross. P1 generation, homozygous dominant cross with homozygous recessive, heterozygous F1, F2 generation with a set ratio, right? That you should always get, just the same as for the monohybrid cross. The complication here is now we have 2 traits. So for each of those traits, we have 2 alleles, like a gene, which controls it, and 2 alleles, and 2 phenotypes. So now things get complicated. But as long as you follow the same principles as what you've learned for the monohybrid cross, this should be manageable. Okay, so now we have two traits. We have seed shape, seed color. And for each of those traits, we have two different phenotypes. We've got round versus wrinkled and yellow versus green. Okay, so these are our homozygous parents. We're going to be homozygous dominant for two genes. So we're going to have round and yellow seeds. These are the dominant phenotypes. And then we're going to have the opposite. We're going to be homozygous recessive for the same two genes. Now, I stretch my back. One thing to be clear is it doesn't matter whether you're homozygous dominant for both genes or homozygous dominant for one and homozygous recessive for the other one. We just put it this way because we don't want to cause you more strife and unhappiness than necessary. But it doesn't matter, right? We just do that out of habit, essentially, right? So the one parent will be dominant for both and one will be recessive for both. But again, it doesn't have to be that way. Yeah. So, question on the board. What are the genotype? First, what's the genotype of the F1 going to be? Think to what the genotype of the F1 in a monohybrid cross is. Then apply that to this. Exactly, but those are going to be together though, right? Because we're talking about the genotype of the individual, not the alleles, or the gametes rather. So yeah, what you're going to get is that. Same answer, just putting it together. What's the phenotype of that individual going to be? Or all of the F1s actually, because they're all going to be the same. What phenotypes are we going to have in the F1s? Yeah, they're going to be round and yellow because they're heterozygous for both genes. So as long as they have a dominant allele for each gene, they will express the dominant phenotype. So they're going to be round and yellow because that's the dominant trait. Not, why am I pointing my screen? You can't see what I'm pointing at. There's going to be these phenotypes. Okay, so I'm going to go through this. Actually, screw it. I'm going to go through it on the whiteboard. That'll be a little easier. Then we can go back to this and go through anything that doesn't make sense. Yeah, it's all right. All right, gotta keep focused, not get distracted by the puppy. Okay, so same principles. P1 generation. We're going to have, I'm going to use colors here because that kind of helps accentuate stuff. Actually, what do we have? We have RR and YY. Y kind of sucks for a letter, to be honest. But anyway, we'll stick with that. Just thinking what's the clearest way to use color. I don't confuse you. Right, so that's one individual. That's going to be crossed to that individual. Okay, so we take the same principles that we learned with the monohybrid cross. What gametes do we have for those individuals? Exactly, good stuff. So we have dominant. It's the only thing you can get, right? Because there are no other alleles for each of those genes. One thing you have to really kind of remember though, is you're going to get one of each. You're not going to get just these two or just these two. You're going to get one of each of those, right? That's really important to remember. Quite often in doing dihybrid crosses, students lose genes, right? So follow this and you'll be good. Right, so that's from the parentals. Cross those together. And now we're going to get heterozygous F1 generation. Okay, so now comes the funky stuff. Or as Prodigy say, here comes the funky shit. So, what gametes can you get from an F1? Almost. For each gamete, how many alleles are you going to get? Going back up here, you're going to have one allele for the R gene and one allele for the Y gene. Right, so each gamete is going to have, well, I mean, obviously it's going to have alleles for all of the genes of that organism, but for what we care about, it's going to have two different alleles, one for the R gene, the round versus wrinkled, and one for the seed color gene. So I'll give you one first up. We're going to have that's one potential gamete. What other ones can we get? Potentially. Because again, remember, this is just based on probability. Yeah, absolutely. Good stuff, Melody and Echo. Oh, yeah, got another one. And there's one last one which we don't have, hence me leaving that gap there. What other possible combination can you get? Oh, I saw him up there, Stephanie. Let's see if someone else comes up with it. What possibility are we missing? Yay, that's the one. Oh, we already got that one, Isaiah. That's here. Exactly. We have this one. Okay, so given that these two alleles are going to segregate randomly, so you're either going to have a big R or a little r in every gamete, and these alleles are going to segregate randomly, either big Y or little y. In these ones, it's all random. So what's the ratio of that you expect for each of these gametes to each other? How many of these are you going to get to these, to these, and to these? Think back to what we did for the monohybrid cross F1s. So if you can get either of these alleles, or either dominant or recessive, randomly, what's the ratio going to be? Yes, it's going to be a 1. Uh-oh. Put my caps back on. Wave my hands around too much. 1 to 1 to 1 to 1 ratio. That's all right, Gina. Yeah, you're going to have 4 possibilities, right? And because it's totally random what each one gets, it's going to be 1 to 1 to 1. Now, the added wrinkle is that we have 2 different genes, right? So for any given gene, which allele you get in the gamete is random. That's the law of segregation. But now we have 2 different genes. Oh, she's sleeping with her tongue out. Can you see that? Cute as that. But now we have 2 different genes, right? And so the law of independent assortment essentially states that whatever you get for this gene has absolutely no effect on what you get for this gene. So these 2 genes are essentially the segregation of the alleles into gametes for these 2 genes is completely independent. This is what we mean about the law of independent assortment. Right. What you get for this gene has nothing to do with what you get for this gene in terms of these alleles. Now we're going to be crossing, we've got 3 minutes, like fastest Punnett square ever. If we don't have time to finish, we'll just continue on afterwards. So we're going to take these alleles, because essentially what we're going to do for the F2 is we're going to cross 2 of these individuals together. So we're going to need these alleles to figure out what we're going to get in the next generation. So we're going to have these individuals. These are our F1s, and they're going to produce these gametes. Let's see if I got space. Yeah. Now you can see why I like having a bigger whiteboard. Right. And these are going to be the F2 generation. So all you do, as before, is you just add them together. That's one individual. That's the sole homozygous dominant for both over here, and you read them off, right? This is what I always do. Well, I guess I could memorize it, but that would be a poor use of my brain. Over here, you'll have, oops, sorry, dog. Turning my dog blue. You'll have our homozygous recessive for both. What I want you to do, partly because we've run out of time, but partly because it's important to do, I want you to make a copy of this, right? I'll obviously post this up onto Blackboard too. I want you to fill out every one of these squares. It's like homework, I guess. Simply by going here and here, I've got, and here I have, right? Do that for all of the squares. Then I want you to go through and count How do I have a dominant allele for both of them? Yes, yes. How many of those do you have? How many do you have a dominant allele for one of them and recessive, homozygous recessive for the other one, and vice versa? And I'll tell you now, you're only going to have one which is recessive. Okay, so that's your homework. Get that done by next class and we'll just review that. Question about the video. So the me, wave my hands around. Those videos are posted to YouTube, and the playlist is in, I think, the first announcement. So give me just a moment and I'll bring up sharing again. Yeah, so for example, this is the Monday, Wednesday, Friday playlist. You can potentially look at those. Here are all the videos from the classes that we've had so far. And obviously they'll have the audio with them. If you have any issues, anybody, with playing back the video, say your internet isn't very reliable or really expensive or whatever, let me know and I can post the audio too. I have all of those. It's not difficult to do. I just only do the video because that has both. So anyway, if that's something that you would want, let me know and I'll sort that out. But yeah, if you check the announcements, you will see the link there. And if you can't find it, just let me know and I'll send it again. Cool. All right, everybody. Thanks very much. Lots of fun. And we'll continue this on Wednesday. So remember, fill that out. It will help you understand where that whole ratio comes from. Cool beans. Catch you later, everybody. See you either tomorrow or on Wednesday.